yet again. And this time we're doing graphing exponential functions from our lesson 7.5. This lesson it's mostly graphing, so I've got my graphing calculator open here, desmos.com/calculator, your best friend on the planet. So let's do it. So the first few problems here ask you to find the value you get when you plug in these different numbers. So 7 to the x. What do you get when you plug in -2? Now you have some options. So first thing is you could come over here. You could type 7 to the -2. By the way, if you don't know how to do what do you call it? The exponent there, you can hit Shift and 6 on a keyboard, or you can click this A to the B button. That'll make an exponent. Now you'll notice it gives you a decimal. Alex does not want a decimal. It'll always want a precise answer, which decimals are technically never. So I'm going to click this, and it'll make it a fraction, 1/49th. And then you could do it. Then you could rinse and repeat, right? You could go 7 to the -1. That's 1/7. I mean, it's much easier once you've typed it in initially. You could type 7 to the 0. Spoiler, anything to the 0 equals 1. So on your problems, you're probably going to be seeing a 1. 7 to the 1. Anything to the 1 should be itself, which is 7. And then the last one is 7 squared, which, again, I hope you know, but you're welcome to type it in if you don't, and you get 49. That's how you do it. Now, I will show you this. Instead of doing that, you could type y equals, or f of x equals, because that's what the problem said. You know, I'll do exactly what the problem says. F of x equals 7 to the x. That's what the problem said. It makes a little graph and everything, right? But if I hit this little gear, it gives me a little option. So again, I'll show you. I hit the gear. There's a table option. And if you click it, it gives you a table. And the table, by default, happens to contain -2, -1, 0, 1, and 2, which are the exact numbers that Alex wanted us to enter. Now, if Alex had ever asked us for 3, you could type in 3. Or if it needed -6, you could type in -6. Oof, -6. 7 to the -6 is a rough number right there. So I'm saying you could do that. Okay, I'm going to back those up a little bit. I don't want you to get confused. But you'll notice when I make the table, it doesn't give me the fraction, and I don't have an option to make it into a fraction, it would appear. So when you do a table, I could see 49 and 7 and 1, but you would have had to gone back and do 7 to the -1, and you would have needed to do 7 to the -2 anyways to get those actual fraction values. So is it really worth putting it in the table? No. We're going to be using these tables more, so, I mean, it could be worth it. I don't know. But for now, I'll just do it this way. This way is simpler. Just inputting this stuff. 1/5 to the, and I'm going to put all the stuff in. -2, that's a 25. Technically, 1/5 to the -2 is... So it's squared, but upside down. So it's 1/25, but flip that upside down, and it's regularly 25. And then I'll do the rest. 1/5 to the 1. 1/5 to the 0. Spoiler, anything to the 0 is 1. Anything to the 1 is itself. I'm just going to skip 2 to save time. And anything to the... Oh, it gave me a decimal there. So if you get a decimal... I think Alex will be okay with a decimal. But I am going to switch it to a fraction. I'm gonna be inputting. Wait a second, that's not 2/5 to the 2. Sorry, I accidentally made it times 2. It's 1/25. I'm sorry, my face is totally in the way, and I can't scroll this. I guess the only thing I could do is, maybe do that and then that there. Sorry. When I stream, I'm allowed to resize the image at will. Where's my Desmos? There we are. When I stream, I'm allowed to resize at will, but I can't do it in the middle of a video recording. Ah, well. All right, so the first two problems were just taking a table, plugging stuff in. I would just use a calculator and plug it in. Pretty simple. The next one says graph the function. F of x. Oof, I can't even speak. F of x equals 4/5 to the x. So I graphed it. There's the graph. If you feel like zooming out, you could, I guess. Doesn't really matter a ton. Maybe it does a little bit. Might need to zoom out a little bit here and there on yours. Now, it says to graph the function, plot the points on the graph with the values -2, -1, 0, 1, and 2, and then click the graph icon. So they want me to literally put 5 dots, which are the 5 dots where I get the outputs of these 5 different inputs, which is exactly what we just did on the tables a second ago, by the way. And then after I graph them, I hit this. So I got great news for you. That's why I showed you this little table feature earlier. If I make this into a table, it plots 5 dots on there, and the 5 dots happen to be exactly the 5 inputs they want. See, they want -2, 1, -1, 0, 1, 2. Oh, look, that's right what's on the table. How convenient is that, right? So I'm going to plug those in. Now, here's the deal. These are all decimals. You don't have to turn them into fractions unless they're repeating. These are not repeating. None of these are repeating. Even this one at the top is 4 digits past the decimal place, but that's okay. As long as it's not a repeating decimal forever, you don't have to bother going back and manually typing it in. I hope I see a problem like that. If I don't, I'll try and force it to find one. The problem is, though, you can't just go on the graph and click -2, 1.5625, right? So you have to go on this little button here. Oop, let me click that button again so you can see what I did. Click this. This is a specific point plotting button. -2, 1.5625. Plot point. -1, see, it lets you keep on going. 125, plot point. 0, 1. I guess I could have graphed that one by hand, but while I'm already in the point plotter, might as well do it. 1, 0.8. The only place you can really mess this up, which you might have seen me just do a second ago there, was typing it in wrong. Please be careful. Just type it in thoroughly, slowly, whatever works. And after you're done putting your points, you click this, and it makes a graph. Wow, that looks just like what I had on Desmos here. Wow, what a big shocker. So that's all you're doing. You're plugging in these 5 values and plotting the points on the graph. The good news is if we use our graphing calculator, it has a feature that literally puts those exact 5 points. Sorry, I'm looking to see if this one will be a weird decimal too. This one's going to have nice decimals too. Now, if I have to do an extra one, I will. All right, this one is 2 to the x. Notice I put my 2 in parentheses. Doesn't matter. Make it a table. There, that's it. So I write the equation. I click make a table. There's 5 points on the graph. Then you put them on Desmos, I guess. Here we go. -2, 0.25. I got a visitor in here. Hello, visitor. What you doing back there?
You can fly the paper from the door.
Oh, all right. They're getting paper for art. So as you may have witnessed there while that was going on, I took each of the inputs and outputs and I typed them in. I didn't have any repeating decimals, so I just wrote the decimals as is. As you saw in the last problem, Alex is totally fine if you use decimals as long as it's not a repeating decimal. These are not repeating decimals. If it was repeating, there would be much more digits, obviously. And I click this and I say that looks just like my graph. And then we huzzah because we got it right. Okay, this problem is very similar to the last one. It wants us to graph those points. It does want one additional thing compared to the last 2 graphs. It wants me to draw the asymptotes, which is going to happen. There you go. I just changed 3. Notice I didn't even have to remake the table. If I already have the table open and I change the function, as long as this says f of x, it knows to use this as the rule. And it did, and it changed the numbers accordingly. Now, here's the deal. I finally got repeating decimals. So what do you do if you get repeating decimals? Well, A, you need to know is what's 0.3 repeating. It's 1/3. Or you have to go back and find it. If you don't know that, you have to actually go back and do 3 to the -2 and 3 to the -1. See how it made those 2 results at the top there? And those were the actual fractions. Desmos will not be happy if you type 0.11111. If you type exactly this, you're exactly wrong because this is 1 forever. Desmos just has to cut it off somewhere. They will be much happier if you typed the following: -2, 1/9, because -2 made this, which we saw down here, is 1/9. -1, 1/3. 0, 1. 1, 3, 2, 9, Perfect. Oh, my face is in the way on here. Oh, darn it. Hold on. Just zoom it like this for a second here. All right, so on this one, if I try and click this, it goes, no, make sure you plot 5 points and one asymptote. It won't let me just plot these 5 points like on the earlier problems. They want an asymptote, which is a dotted line. Now, the asymptote for us is a horizontal line. We discussed it in class. Well, the asymptote's basically, what's the place in time where the graph no longer... Whoa, easy there, video. Where the graph no longer goes down anymore. See how like it evens out and seemingly goes to 0? Spoiler alert, as we said in class, this doesn't actually go to 0. It's just so... If I zoom in... Hold on, I'm zooming in. We're zooming in. Zooming down to microscopic levels. It's really zoomed in. How zoomed in does it gotta be? This zoomed in. You can see it's not actually 0. It's not actually 0. But when I zoom into a regular size, it says 0 because, I don't know, it rounds or whatever. So I'm just saying, the asymptote means what's the place that it's never going to hit. It's never going to hit 0. It's never going to hit y equals 0. If I draw this little line like that, you'll notice it's not actually going to hit that line, right? And if I zoomed in, you'd see the red line is just above the blue line all the time. So I need to make that on my graph here. So I make a horizontal line at 0. Then you click it. Fun fact, on these exponential functions, you'll never have a vertical dotted line needed. You don't have to use it. On these, you shouldn't use it. Like, if you use it, it's just there to throw you off. So all you want to do is, like on the last problem, is make 5 dots by plugging them in, using a table, and then make a horizontal asymptote. On this problem, it's at 0. It's not always going to be at 0, but I'm going to tell you right now on this assignment, I think it's going to be at 0. In the future, it's not always going to be at 0. Hooray! Continue. Alright, here comes another one. Let me adjust my screen here. There we go. Okay, this one wants 1/3 to the x. It should be... Now, hold on. I need you to notice this. This isn't going to be necessary for you on your assignment. But did you notice that when it went from 3, look at those numbers in the table. I suddenly make it 1/3. I try to do it fast and cool. I make it 1/3 and suddenly it's that. Again. 3. 1/3. 3. 1/3. They're literally the reverse of each other. The reason why is because when you do 3 to positive numbers, you get 9 and 3 and 1. Or, well, 0, 9 and 3. And then when you did it to negative numbers, it made these decimals. But when you do 1/3 to the negative numbers, it makes the positives because you're flipping stuff upside down, right? So do I really need to go through and find all this stuff? Probably not. But if you really want to do 1/3 to the 1, and you really want to do 1/3 to the 2, and figure those things out, you totally can. By the way, where'd my graph go? Oh, there's my graph. Ta-da! Hey, look, you can see the asymptote also is at 0. Now, this one looks different because the last one was rising. This one is falling. That's typical of fractions. Still got to go through and type in all these numbers. Here goes nothing. -2, 9. -1, 3. 0, 1. 1 and 1/3. 2 and 1/9. I think those are right. Then I have to make the asymptote. Oh, you guys couldn't see that. You can't see it again. Sorry, my fat head's in the way. So make a horizontal asymptote again at 0. Then I click. I'm hitting check. It's behind my face. Then I hit continue. Lovely. Oh, my head is still in the way. This shows enough. The graph of the exponential function is shown in the below. The horizontal asymptote is shown as a dashed line. Find the domain and range. So they want you to say state the domain and state the range. Guys, I got great news for you, and you can always guarantee you're half right on these. The domain of all exponential functions is all reals. All real numbers, technically, but all reals. Because it goes right forever and left forever. There's no point to the right where you wouldn't see some piece of line. There's no point to the left where you wouldn't see some piece of line. Now, the range, on the other hand, is not everywhere. There's certain heights up here. You would never see the line at this height. Like if I said, hey, show me where the line is 5 high, it's not going to happen. because it has this asymptote that says, hey, the line can't go any higher than this. So there's a limit. It does go down forever, though. So the way you want to write this is this. You want to say y. Now, you have two choices here, essentially. You're going to have greater than or less than. You should never have the equals to. It does give you equals to options, but equals to would only be if it actually hits the asymptote, which that's what the definition of asymptote is. It will never hit it. So your choices are y is greater than, y is less than. And that really depends on how the graph looks. Like my graph is going down, so which means the y value is always less than something. There's some maximum height that they're always less than. And in my case, it's -1 because the dotted line is -1 height. The graph is always -1 in height on the y-axis or lower. So that's what I write. Hopefully the next one is the other way. Oh, good. It is the other way. Good. So make sure you read, because mine says range first, then domain. Those tricky guys. So make sure you find domain and put all real numbers. My last time had domain first, okay? So make sure you're reading what they want. Don't always assume it goes domain then range. I know when we do math we say domain and range, but like I guess they wanted range and domain, so read careful, okay? All right, here's my range. It's y. You always got to have y, and then you, again, as I said, greater than or less than. This time greater than, because it's always above a certain place, and this certain place is -4. That's it. All you need is to put domain is all real numbers, and the range is greater than something or less than something. Depends on how the graph is. If the graph is going up or down, or where it's crossing at, you know. That's it. That's all there is to it. Oh no, I just realized this late in the video that I hit stream. Oh man, I streamed it. Oh, that's okay. I can still get a YouTube worthy video of this. I'll just download it. Lame. Oh no. Oh no, no. Gotta hit submit assignment. Was anybody watching the stream? I'm gonna have to find out now if anyone's actually watching the stream. I didn't have my stream details open. I have no idea if anyone was talking to me this whole time. Gosh, I hope you weren't. All right, so let's recap. There were two problems that gave us a table, and we needed to find out what the outputs were for the given inputs. All I did was take a calculator and type it in. I typed 7 to the -2, -1, 0, blah, 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 and I got this stuff. Make sure you convert to a fraction. That's the first two problems. Second two problems, we had to make a graph, and the way we made a graph was I input this right here into Desmos.com, and then I converted it to a table. Hold on, let me do this. Sorry, excuse me. I converted it to a table. Again, that's the gear button to make tables. And then I plotted the points. If the points were repeating decimals, we needed to convert it to a fraction, which usually meant going down here and like reevaluating it manually, which is not fun, but is it really that hard of work? You don't even have to think. You just have to know what to do, which is why I make the video, so you know what to do. You know what I mean? So we had two problems like that. So two tables, two graphs, then two more graphs, except for these graphs added one additional thing. They wanted you to find the asymptote line and put that on there. Whoop. And then we had two final problems that said, what's the domain and range? And the domain should be all real numbers, and the range should be y is greater than or less than whatever the asymptote is. I had -1, and I had -4 on the following problem. And that's what I got there. Well, if you're watching this live, that's very interesting. I'd be interested to see if anyone